solve these quadratic simultaneous, so they're both rearranged for y, so we can just equate them together. Y equals 4x and y equals x squared plus 3, so 4x equals x squared plus 3. Move the 4x over, and here we can factorize. So we would have x and x, 3 and 1. To make minus 4, we need both of them to be negative. Then either x minus 3 equals 0, or x minus 1 equals 0. Move the minus 3 over, x equals 3. Move the minus 1 over, x equals 1. Then we just sub it into any of the two. I think subbing into the y is easiest. So it says y equals 4x. Wherever the x value is, you times it by 4. So if x is 3, times it by 4, we get 12. If x is 1, times it by 4, you get 4. So our two solutions as coordinates are these two. Part B, a little bit trickier. We need to do some rearranging first. Now remember, we cannot rearrange for any term that's not linear. Also, we cannot use elimination here. So we can't times by x and do subtractions. Now it's much easier to rearrange for the y term in the second equation. The negative y, you just move it to the other side. Remember, we call this the subject equation. Now in equation 1, wherever we see y, we're going to replace it with 2x plus 1. So we get x squared minus 3 bracket 2x plus 1 plus 11 equals 0. Then we expand x squared minus 6x minus 3 plus 11 equals 0. X squared minus 6x minus 3 plus 11 will be plus 8. Factorize. Now here we're going to be using 4 and 2, and both minus. Now remember what we said, x minus 4 equals 0, which means x equals 4, or x minus 2 equals 0, which means x equals 2. Then we take the x values and we always sub it into our subject equation because that's always rearranged for the other variable. So y in this case will be 2x plus 1. So y would be 2 times 4, 8 plus 1, 9. Then for this one, y equals 2x plus 1. So y is 4 plus 1, 5. So our two solutions are 4, 9 and 2, 5. Hey guys, I hope you're enjoying the video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button and comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video. Question 4. Neil and his niece Lara both had their birthday yesterday. Today Neil's age in years is an even number and 15 times that of Lara. In 4 years' time, Neil's age in years will be the square of Lara's age in years. How many years older than Lara is Neil today? So what you want to do is always make the smaller person's age x, or any smaller quantity, let it be x. So for Lara, we'll make that be x, and for Neil, it says, today Neil's age in years is an even number and 15 times that of Lara. So if we have x, we have 15x for Neil. In 4 years' time, Neil's age will be the square of Lara's age. So in 4 years, both ages will have gone up by 4. So Lara's age will be x plus 4, and Neil's age will be 15x plus 4. And it's saying, my age will be the square of Lara's age. So if you square Lara's age, it will give you my age. Then we need to expand and solve. So writing this bracket out twice, you would have x plus 4x plus 4. So we would have x squared plus 4x plus another 4x is 8x. Then we have plus 16 is 15x plus 4. Move everything over to the left side. Now we factorize. Then we're thinking, okay, what multiplies to give you 12 and adds to give you 7? That's going to be 4 and 3. Both minus. So x minus 4 equals 0 and x minus 3 equals 0. So you'd get x equals 4 and x equals 3. Now that's Lara's ages. So my age, remember, is 15x. So 15 times 4 would be 60. And 15x here, 15 times 3 is 45. Now, if you read in the question, it says that Neil's age is an even number. So it looks like this is not the situation we want. So it says, how many years older than Lara is Neil today? So today, my age is 60 and Lara's age is 4. So we just do 60 minus 4. So the answer there is 56 years. Here is a rectangle and right-angled triangle. The area of the rectangle is greater than the area of the triangle. Find the set of possible values of x. So the area of the rectangle is base times height. So it'll be 2x times x plus 4, which you might as well expand that. So 2x squared plus 8x. Now for the triangle, we're going to have a half times the base length times the height. I'm just going to write the height one first because it's actually easier in this case. Because you could do a half of 6, which is 3x, x minus 3. Then we just expand that. So we have 3x squared minus 9x. It says the rectangle is greater than triangle. So the rectangle's area was this. It's saying it's bigger than the triangle. Now we need to solve. Bring all these smaller x's to the larger one. So all of the left goes to the right. And in this case is less than 0. Yeah, so sometimes it's better to write it the other way around. So x squared minus 17x less than 0. Now to solve this, we need to factorize our x. So we'll be left with x minus 17. So you have two solutions, x equals 0. Let's do our sketch. 0. Or x minus 17 equals 0, which makes x 17. So like that. Then you just want anything underneath. So you just want any of these x values. So you want anything between 0 and 17. And it can't equal 0 and it can't equal 17 because of the way we've fixed the inequality there. Now on another note, this is not actually the final solution. It seemed like an easy question, but this is a kind of question which catches a lot of pupils out. Now, there's a hidden inequality here that we need to consider. 0 obviously can't be allowed here because if you take 0 and sub into 6x, it gives you a 0 length. But based on this inequality, 1 technically is allowed. But if you take the number 1 and you sub into x minus 3, it gives you a negative length, which then means we need to consider the fact that what values of x do we need to ensure that this length remains positive. And for that to be true, for x minus 3 to remain positive, is that x needs to be bigger than 3. Which actually means then that this is not the final answer. The final answer is that x has to be between 3 and 17. That's a trick question.